Black holes are structures in space that were discovered relatively recently and remain largely enigmatic, with their mechanisms still not fully understood. These mysterious phenomena, from which no matter or even light can escape, continue to baffle scientists with the secrets they may hold. While we know a few things about black holes, much of this knowledge is rather basic. For instance, it is well established that any object crossing a black hole's event horizon can never escape and will inevitably be pulled into the black hole. Beyond this fundamental understanding, many theories about black holes have been proposed. One of these suggests that black holes might act as portals, instantly teleporting objects to another part of the universe within seconds or even milliseconds. Of course, many of these theories are far-fetched and largely belong in the realm of science fiction. Today's video will explore the fascinating scenario of what might happen if one of these black holes were to consume our sun and take its place. How would this event impact our planet and the solar system as a whole? Let's dive into this intriguing topic. First, let's list the planets in our solar system in order of their proximity to the Sun. The closest planet to the Sun, and also the smallest planet in the solar system, is Mercury. Mercury has no known moons or rings, and although it is the closest planet to the Sun, it is not the hottest. The next planet after Mercury is Venus, which holds the title of the hottest planet in the solar system. This is primarily due to the thick greenhouse gases in its atmosphere. Interestingly, Venus rotates in the opposite direction of most other planets, meaning the Sun rises in the west and sets in the east. Following Venus is our beautiful Earth, the only planet currently known to harbor life on its surface. After Earth comes Mars, also known as the Red Planet, which is believed to have once supported life. Next is Jupiter, the largest planet in the solar system and the one with the strongest magnetic field. The sequence continues with Saturn, Uranus, and Neptune. You might recall that Pluto was once considered a planet. However, it has since been reclassified as a dwarf planet. Let's talk about our Sun. The Sun is the primary source of energy for all the planets in our solar system and sustains them. Throughout human history, the Sun has been more than just a star. It has been regarded as a deity in various mythologies and featured in countless religious and mythological narratives to illustrate the Sun's impact on life on Earth. Let's consider this. Plants rely on sunlight for photosynthesis to grow and reproduce. These plants serve as a food source for herbivores. In turn, carnivores and omnivores consume herbivores as their food source. If you remove the sun from this chain, plants can no longer photosynthesize, which means they cannot grow or reproduce. This results in the extinction of herbivores due to the lack of food, and subsequently, carnivores and omnivores face starvation and extinction as well. The sun's influence on life on Earth is not limited to this example, but can be best summarized in this simple way. The Sun has been burning for approximately 4.5 billion years and providing life to the planets in the solar system. It is primarily composed of hydrogen and helium gases and has an incredibly strong magnetic field. This magnetic power keeps all planets, moons, and debris within the solar system in orbit. Although the Sun is not the largest among all stellar types in the universe, it is larger than most. For instance, it is relatively small compared to red giant stars, but significantly larger than red dwarf stars. By universal standards, the Sun is considered an average-sized, middle-aged star. The Sun accounts for about 99.86% of the mass in the solar system and has a diameter of 1.4 million kilometers, making it 110 times the diameter of Earth and about 1 million times Earth's volume. In other words, approximately 962,000 Earths could fit inside the Sun. As mentioned earlier, the Sun is mainly composed of hydrogen and helium, but it also contains small amounts of oxygen, carbon, nitrogen, silicon, magnesium, neon, iron, and sulfur. The Sun's hydrogen undergoes a fusion reaction, converting into helium, preventing the Sun from collapsing inward. Therefore, Hydrogen is often referred to as the sun's fuel. However, this fuel is not infinite. One day, the hydrogen will be depleted, causing the sun to collapse and ultimately die. During this collapse, it will eject denser elements into space. While the exact timing is unknown, scientists estimate this will occur in approximately 4 to 5 billion years. The distance between Earth and the Sun is roughly 149 million kilometers, fluctuating between 147 and 152 million kilometers. If Earth were not within this range, life would not exist here. It takes 8 minutes and 20 seconds for sunlight to reach Earth. Simply put, if the sun were to vanish right now, we wouldn't realize it until 8 minutes and 20 seconds later. Despite the 149 million kilometer distance and the protective ozone layer in Earth's atmosphere, sunlight can still harm human skin and eyes due to the immense energy emitted by the sun. To put this energy into perspective, the sun produces as much energy in 1 second as a 1 megaton bomb. The sun is located about 25,000 light years from the center of the galaxy. This means any event occurring on the sun would take 25,000 years to reach the galactic center. This distance highlights the awe-inspiring scale and mysteries of the universe. Additionally, the sun completes one orbit around the Milky Way center every 225 to 250 million years. This concludes our current discussion on the sun. If you're interested, in our next video, we can dive deeper into fascinating details about the sun and explore its most intriguing aspects. Next, we turn our focus to black holes, objects or phenomena that lack a clear structure or form. Black holes are celestial entities moving through space, so dense that no matter, not even light or radiation, can escape their gravitational pull. Astronomically, black holes are defined as the most compressed and dense celestial objects, typically formed when massive stars end their lives in a supernova explosion. In simpler terms, black holes are dead stars. Like our sun, stars eventually run out of fuel and collapse in on themselves, creating these mysterious structures. The event horizon of a black hole has such immense gravitational force that even light cannot escape once it passes this boundary. The inability of light to escape is why black holes have no visible color or shape and are named as such. By defying the laws of physics and science to an extreme degree, black holes have become a frequent subject of science fiction films, scientific research, and academic discussions. Black holes were first predicted in 1915 as part of Einstein's theory of general relativity. According to this theory, any object compact enough can bend spacetime sufficiently to form a black hole. Essentially, the formation of a black hole involves reaching a point where, at a certain distance from the object center, escaping would require speeds equal to or greater than the speed of light. It's important not to generalize black holes solely as remnants of collapsing stars. While many black holes do result from supernovae, others may form through entirely different processes. For example, the collision of two massive planets or celestial bodies could generate enough energy to create a black hole. This raises a common question: how massive does an object need to be to form a black hole? Every celestial object has a minimum mass threshold for black hole formation, known as the Chandrasekhar limit. This limit is approximately 1.4 times the mass of the Sun, but is generally estimated to fall between 2 and 3 solar masses. Numerically speaking, a star must have a mass of at least 1.4 solar masses, equivalent to 2.784488001.602 for 17,000,000,000,000,000,000,000 kilograms or 2.7 nonillion kilograms to potentially form a black hole upon its death. There are many types of black holes, but today we'll focus on two main categories. First, let's discuss primordial black holes. These black holes are thought to have formed during the early moments of the universe, during the massive explosions accompanying the Big Bang, and have persisted to this day. The second category includes stellar black holes and supermassive black holes. These are formed through star collapses and supernovae, though their exact nature and composition remain a mystery. Black holes are incredibly dense objects. Density and volume are inversely proportional. The greater the density, the smaller the volume, and vice versa. To illustrate the density of black holes, imagine a teaspoon holding material as dense as a black hole. If expanded to its normal size, this material might encompass the entire Earth, yet because it is so compacted, it is incredibly dense. No force on Earth, no matter how powerful, could move that teaspoon. There are countless theories and topics to discuss regarding black holes. As we mentioned with the Sun, we can dedicate a future video to providing more detailed insights into black holes and exploring the fascinating theories surrounding them. Now, let's imagine a scenario where scientists suddenly discover a massive black hole hiding behind the Sun, concealed by its brightness. Upon further investigation, they realize that this black hole is much larger than the Sun and is on a path to consume it. What kind of events would unfold on Earth in such a situation? First, despite the imminent destruction of the world, governments and tech giants might focus on retaining their power. They would likely sell exorbitantly expensive tickets for spaceships designed to escape Earth. Meanwhile, scientists around the world would work tirelessly, conducting experiments and searching for solutions to save the planet. As the black hole rapidly approaches the Sun, its enormous gravitational force would already start affecting Earth and the other planets. Volcanoes across the globe would become active, resulting in countless eruptions daily. Massive tidal waves and tsunamis would arise in the oceans, and enormous earthquakes would shake all continents. People in every country would seek refuge in underground bunkers and newly constructed, highly secure shelters to shield themselves from these natural disasters. As the black hole draws closer, the orbits of Earth and other planets would destabilize. Each passing day, the effects of the black hole's gravitational pull would intensify, and scientists would find themselves running out of time. Eventually, the Sun would be consumed by the black hole. Following this, the black hole would begin engulfing the other planets, and Earth, too, would cross its event horizon, leaving no chance of escape. In a final attempt to save humanity, scientists might modify spacecraft powered by solar energy and other thrust-generating forces in space to travel at incredibly high speeds. These advanced spacecraft would be humanity's last hope. However, due to limited resources and deep societal divisions, many people would be left behind on Earth. Sadly, most of the population would perish in the disaster. As the black hole's gravitational pull grows stronger, Earth's shape would become distorted, and the continuous earthquakes and volcanic eruptions would make standing upright nearly impossible. After about a week, the spaceships would launch into space, leaving behind a devastated Earth. Those who managed to escape would look back at their home planet for the last time, witnessing its destruction by the black hole. They would bid farewell to Earth with immense sorrow. However, the hope of those who escaped would not last long. The black hole's gravitational pull is so immense that, no matter how fast the spacecraft traveled, they could not reach speeds close to or exceeding the speed of light. Eventually, the spaceships, too, would be pulled in, sealing their fate. Even as they were drawn into the black hole, scientists aboard the spacecraft would continue their desperate efforts to find a solution. Unfortunately, escape would no longer be possible. As the spacecraft entered the black hole's event horizon, they would begin to disintegrate, with many engines failing. The distortion caused by the immense gravitational pull would stretch the ships and their occupants into long, thin strands, a phenomenon often referred to as spaghettification. Surprisingly, even as their physical forms stretched and distorted, the humans would remain conscious, aware of their situation, but incapable of logical thought. Over time, they would lose all sense of identity and understanding, becoming like lifeless shells. In the end, all spacecraft, the Sun, and the entire solar system would be consumed by this supermassive black hole. Humanity, the only known intelligent life in the universe, and the Earth, the cradle of life, would meet their end. Some speculative theories suggest that planets and spacecraft swallowed by a black hole would emerge in another part of the universe. However, realistically speaking, such a scenario marks the absolute end. In conclusion, the arrival of a supermassive black hole in our solar system would lead to this chain of catastrophic events. Fortunately, the likelihood of such an event occurring is even lower than humanity achieving light-speed travel. So, rest assured, that's all for this video. As always, if you'd like us to create a more detailed documentary about black holes or the sun, let us know in the comments. Don't forget to subscribe to our channel and like our videos to help them reach more viewers. See you in the next video. Take care and stay safe.